Okay, in this video I'm going to introduce the product rule and do some examples. The product rule is a rule that we use anytime we're multiplying, um, anytime we have an expression, I'm sorry, anytime the function um, can be thought of as a product of two expressions, both involving x. So for example, if I have f of x equals 3 times x, it's a really simple one. This is it can be thought of as two expressions multiplied together, 3 times x, but both of them don't involve x. So this would not be a case where I apply the product rule. However, if I have something like x sine x, you could think of this function as the expression x times the expression sine x. So this would be a case where you need to use the product rule because you have two expressions multiplied together and both of them involve a variable. Another example might be x plus 3 times x minus 2. Now here's one where when you first look at it, this is definitely could be thought of as an expression times an expression, both involving x, so you could use the product rule here. However, you could take an algebra move right away and multiply this out, so you'd get x squared, and 3x plus negative 2x would be plus x, and 3 times negative 2 would be negative 6. And then in this case, you wouldn't have to use the product rule. So what I'm suggesting is if you use the product rule to take the derivative of this function, you would get the same result if you just multiplied it out first and use the power rule and the addition rule to take the derivative of this function. You should get the same result. Okay? So again, that's the idea of the product rule. There is two expressions being multiplied together. So when we look at this one up here, this is the power rule written out in two different notations. You should be familiar with both notations because they both come up in web work and in my videos. I'm going to use both. So you don't want to say, well, I like this one, but I don't like that one, so I'll just not worry about it. You got to know both. Another one that's probably that you might see that I am less promoting is just using the prime by itself. So in other words, if you had y equals uv, some people might write like this with little prime, meaning this means dy dx, u prime v plus v prime u. That would be a third way to write out the product rule. This one I think is a little bit dangerous because the primes can easily get lost and it's not clear which one has a prime and which one doesn't. So I usually don't use that, although I will use it occasionally when I'm trying to do a problem and I don't want to have to rewrite the dy dx and dv dx over and over again. Okay, so let's look at this. Basically, when you look at the product rule, what you see is it's the product of the derivative of the first times the second plus the derivative of the second times the first expression. So and it doesn't matter what order it goes in. I could have taken the derivative. In other words, I could have put this first and that second. It doesn't really matter because you're adding them together. So we all know that order doesn't matter in addition. So let's look at one of those that we just talked about. If we say h of x is equal to x sine of x, right? Well, the derivative of that would be, now if we think of this guy, and this is what I like to do actually when I'm doing a problem is, I'm going to, in fact, let's draw in some highlighting because that makes everything better. So we're going to color that that yellow and this green, just so you can kind of tell them apart. There's the two pieces of the product, if you will, and we're going to call this one U and this one V. Okay, so the yellow is U and the green is V. So that means I want, first of all, du dx times v plus dv dx times u. Okay? Kind of mix a notation here, aren't I? So let's change this to, so we don't mix notation, dh dx. All right? Now, so then what we need to do, and this, you probably don't need to do this in this case because it's so simple, but sometimes what I suggest is go off to the side and write your du dx over here. And the derivative of u in this case would just be 1, because, or let's do it, this would be dx dx, of course, which is just 1. Okay? And then dv dx, that's going to be equal to the derivative of sine x, which we all know is cosine x, times dx dx, which is just 1, so we don't bother writing it. So now we know what du is, du dx and dv dx is. So then I'm going to come back over here, and I'm going to just place du is just 1, times v, which we know is sine x, right? Plus dv dx is cosine x, times u, which was x. So in the end, we have sine x plus x cosine x. We usually move the x to the front of the cosine because that way we don't get the x confused. Because this would not, we all know that would not be cosine x squared, right? Because the cosine is surrounding the first x. And this is x is being multiplied on the outside of the cosine, so really it's better to write it like this, x cosine x. Okay, so there's an example of the product rule. Another example would be, let's say we have y is equal to 3x times e to the x. Okay? So if we're going to do the product rule here, we'd say dy dx is equal to, well, we need, let's call this guy u and this guy v. So I want u, whoops, I want du dx times v plus dv dx times u. And what is du dx? Well, that's just 3. 3 dx dx, which is just 1, so it's just 3. And dv dx is e dx dx dx. Okay? So then we go back over here and say dy dx, that's equal to, let's see, that'd be 3 times v, which would be 3 e to the x, plus dv dx, that would be 3x times e to the x. Because we want, this would be, so there's my u, and there's my dv dx. Okay? Now, just for fun, let's look at that one we were talking about before that could be done either way, and we'll do it either way. So let's say it's x. I don't remember what it was, so I'll just make up one like it. So if we were doing this using the product rule, we would say dy dx is equal to the derivative of that, which would just be 1, times that, x plus 4, plus the derivative of the second one, 1 times that, x minus 2. So in the end, we'd have dy dx is equal to, well, we got x plus x, which would be 2x, and 4 plus negative 2, which would be 2. So that would be using the product rule. Okay? Now, if we were to change this first and rewrite it as x squared plus 2x minus 8, that's what you get when you multiply that out, then dy dx, now I don't need to use the product rule. I'm just going to use the power rule here. That would be 2x, or 2 times x at first, plus just 2, and notice we get the same thing. So, now let's just go to take one more step. A little bit of difficulty here. Now you can see this gets a lot more difficult if the individual expressions are more complex than what we're doing. We're just doing kind of some simple expressions right now, but let's just take it up a little bit further. Let's say we have y equals x e to the x times sine x. Okay, so Now we have three expressions there, really. Three expressions involving x. And so you could, because you have x times e to the x times sine x. So the product rule, you notice, is only referring to two expressions at a time. So what we do in this case is, and I'll be really careful on this, is I'm going to just break them up randomly for myself and say, okay, there's my first expression. Well, not randomly, there's a reason behind it, and there's my other expression. Okay? So then I'm going to call this my u and that my v. So over here, I need to know what du dx is. Well, when I take the derivative of u, I'm going to have to use the product rule again, aren't I? So this is going to be the derivative of the first, which would be 1, times the second, e to the x, plus the derivative of the second, that'd be e to the x, times the first, which would be x. So du dx is equal to e to the x plus x e to the x. Yeah? And dv dx is equal to cosine x. So notice I just paired up, I just created a u and v for me to begin with so that I'm only multiplying two things. So this is one expression, this is the other expression. They're being multiplied together, so I have to use the product rule. But then when I go to take the derivative of the u, I use the product rule again. So it's like the product rule inside of the product rule. Okay? So then I'm going to come back down to here, and I'm just got to take u, the derivative of u, which is right here. That would be e to the x plus x e to the x, times v, that's sine x. And then I need the derivative of v, which is right there, cosine x, times my original u, which would be x e to the x. Now let's real quickly do a little bit of highlight here so we can see where everything ended up. So see, this goes with that yellow, right? This is the derivative of u. So he shows up right there. And then again, just the u. That's my u and that's my du, right? And then the green, of course, is right there, there, and there. Okay? And just to make it abundantly clear, this is my du dx, this is my v, this is my dv dx, and this is my u. Okay, and then of course we'd simplify this a little bit, so y equals, I could distribute that sine x through, so that would be e to the x sine x plus x e to the x sine x plus x e to the x cosine x. And that would be my final answer. Okay, so that's the product rule. There's a lot of opportunities to practice that, both in web work and on some of the sheets I post in Canvas. And so you want to get good at that method. Now, one thing that's not the product rule, I want to show you this. For example, what if y equals cosine x squared? There's a temptation to think that this is cosine times x squared, but hopefully you've all overcome that temptation, because we all know that cosine by itself means nothing. There has to be an argument, so it's always cosine of something. So in this case, the x squared is inside the cosine. So this is not a product rule. Not product rule. This is actually a chain rule, right? We handle this with the chain rule, because chain rule is what tells us what to do when we have a function inside of a function. So in this case, if we apply the chain rule, dy dx would be equal to the derivative of the outside. The derivative of the outside is, what's the derivative of cosine? So notice we're not going to look at x squared at all. We're just looking at the outside function, which is cosine. What's the derivative of cosine? That would be negative sine. And notice the x squared is still in there, because I just took the derivative of the outside. The outside was cosine, and the derivative of cosine is negative sine. So then the chain rule says the next thing you do is you multiply that by the derivative of the next innermost function. So in this case, the next function is x squared. So then I'm going to multiply this by the derivative of x squared, which would be 2x. And then finally I derive it by the are multiplied by the derivative of x, which is dx, which of course is just 1. So I don't need to write that. And so then that would be my derivative. Probably clean it up a little bit by writing negative 2x times sine of x squared. Okay, so that's a chain rule. This is not a product rule. This is a chain rule because the function's inside the function. Another quick example of that. Again, this is a product rule video, but I'm helping you see what's not a product rule. Like, for example, e to the 2x. Okay, this is not e times 2x, this is e to the 2x, where the 2x is inside of the e to the. So when I take the derivative of this, dy dx, the derivative of the outside, e to the, that's just e to the, right? So the derivative of the outside would just be e to the 2x. Then I'd have to multiply that by the derivative of whatever's in the inside the e to the. So I'm taking the derivative of 2x, which would of course just be 2. And so then my final result is 2e to the 2x. Let's give another version of that, a little bit more complicated. Let's say we have y equals e to the sine x. Again, this is not a product rule. This is, you're raising e to the power of sine x, so essentially the sine x is inside of the e to the. So this is a composite function where e is the outside function and sine is the inside function. So we're going to take the derivative of this. First thing we do is take the derivative of the outside, which is e to the. Well, the derivative of e to the is just e to the, whatever it was. So this would be e to the sine x. But then we'd have to multiply that by the derivative of what's inside the e to the. And the derivative of sine, of course, is cosine. Okay, so that's the product rule. Have some fun with that. And practice it till you get good at it. And then practice it some more.